to special right triangles. We did regular right triangles when we talked about 8-1 on Thursday. If you were asleep for that, I would recommend watching that video. So now we're going to talk about special right triangles. So there are two forms of special right triangles that we rely heavily upon. There is our buddy, the 45, 45, 90. They have a special relationship. We'll go over that. We'll do a couple of practice problems. Well, we did a couple of practice problems with that on the 8-1 assignment and on the radical review worksheet. So in a 45, 45, 90 triangle, the hypotenuse, in case you don't know where the hypotenuse is, I drew my little picture of the man so that we always, we know what a leg is, we know what a leg is, and we know where the hypotenuse is. The hypotenuse is √2 times as long as each leg. So if you know what the leg is, you can find the hypotenuse by multiplying it by √2. Super easy. So here's the little formula. Hypotenuse is equal to √2 times the leg. And we can even write another equation. If you can just fill out this equation, you guys are good enough at algebra, you can solve for the leg, but let's put it down just while I have you here. So if you have the hypotenuse and you want the leg, you just take your hypotenuse and divide by √2. If you have the hypotenuse and you want the leg, you take the hypotenuse and divide by √2. That's a bonus. That's not on there. I'm giving you guys some gold magic there. The next special right triangle that we encounter is a 30, 60, 90. So the little angle is 30, the medium angle is 60, and the big angle is 90 degrees. In a 30, 60, 90, we always give our short leg. So you guys please draw the picture if you don't have the picture on your paper. We always give the short leg, he gets to be x. The hypotenuse is 2 times x. The longer leg is √3 times x. The way I remember this, my friends, so if you are stranded in the middle of the desert and you don't have access to the internet and there's no notes and the battery died on your phone, and you need to, for some reason, do special right triangles, this is how I remember. 45 times 2 is 90. So the relationship in the 45, 45, 90 is the √2. 30, 60, 90. 30 times 2 is 60. So one of the relationships is times 2. 30 times 3 is 90. So the other relationship is √3. So because my brain wraps around numbers like that, I'm all, yeah, so one of them is √2 and the other one is 2 and √3. And then if you want, I would like it thinner, please, Mr. Man. So if you want the short leg, you can take the hypotenuse and divide it by 2, or you can take the long leg and divide it by √3. That's bonus. You're not going to get this anywhere else, guys. It's bonus magic. Bonus awesomeness. Okay. You guys have this written down? You ready to move on? Okay. Let's do some problems. Woohoo! Okay. The first two triangles are going to be 45, 45, 90s. So we're going to, I grabbed the hypotenuse is equal to √2 times the leg. And remember, because 45 times 2 is 90, we use the √2. That's my remembering mechanism. Find the length of the missing sides of the triangle. We'll go green on this guy. So we know that this is 45, we know that this is 90, we know that the other guy has to be 45 because there are only 180 degrees within a triangle. Okay, 45, 45, 90. The hypotenuse is here. This guy is a leg, and this guy is a leg. So we can say that the hypotenuse is root 2 times the leg. Well, we know y is going to be equal to whatever that other leg is, and that's equal to 3. 45, 45, 90 is always an isosceles triangle, so the legs are going to be equal. The hypotenuse is root 2 times the leg. In math, we like to put the whole numbers in the front and the radicals after. So we write this as 3 root 2. My 2 went a little sideways for me there. That's okay. All right, we're going to do that same thing, but this scenario in scenario B, example B, we're going to have the hypotenuse but not the legs, and you guys are going to see rationalizing the denominator. In case you missed it, this stuff, rationalizing the denominator, is riveting. It's going to seem like extra steps, but I promise you if you do that, on all of your standardized tests, your placement tests, your test to become a postal worker, your test to work for the county, you'll be able to rationalize the denominator. I don't know why it still hangs around. We could just put it in our calculators and be decimally, but whatever, it's fine. So the hypotenuse, which is 5, is equal to root 2 times the leg. If you have trouble, the hypotenuse is always across from the 90 degree. Okay, so we are looking for x. So we divide by root 2, and we know x is equal to 5 over root 2. Here's a dilemma. People in the math world, they got together and they said, you can't have a root on the bottom. There was a great reason for it in like 1950, but now that has gone away. Unfortunately, it still hangs out and we have to rationalize the denominator. I apologize for math kind everywhere, but that's just, but if I don't warn you about it, it's like going to the DMV. If I don't warn you about it, then then it won't be a thing. Okay, so we have to rationalize the denominator. So we have to get the root out of the denominator. The best way to do it is to multiply the top and the bottom by the root. So you just take whatever that root is and multiply top and bottom by the root. On the top, we get 5 times root 2. On the bottom, there is special, beautiful something that happens when you multiply root times the root. What's 2 times 2? 4. What's the square root of 4? 2. So when you multiply the same root by itself, you get the number without the root, which is why we do this, because we don't want the root in the denominator. You guys play enough video games to know that there's sometimes there's special rules that you're like, that's really annoying, and it doesn't make any sense for the game, but you play along anyway because it's rules of the game. All right, these are the 2 scenarios you find for 45, 45, 90. You'll have the leg and need to find the hypotenuse, super easy, or you'll have the hypotenuse and need to find the leg. 30, 60, 90. The short leg is always across from the little angle. So if you're looking for the short leg, he is across from the short angle because the angle opens up as much as the leg allows it to. So the more your angle opens, the longer your leg. The less your angle opens, the shorter your leg. So Your short leg is always going to be across from your shortest, your smallest angle. Your long leg is across from the middle one, and your hypotenuse is always across from the 90 degrees. Okay. The rule is your hypotenuse is 2 times the short leg. So we're going to go, short leg is x. So hypotenuse is 2 times x. We've gotten nowhere because we don't have the short leg. Okay, what's the other one? The longer leg is root 3 times the shorter leg. Okay, let's put that together. The long leg is 5 equals root 3 times the short leg, which is x. Okay, it's a little algebra, but we can solve it. We divide both sides by root 3. I would like red. And we get x is equal to 5 over root 3. But we cannot have a root in the denominator, so we need to multiply both sides, or the top and the bottom, by root 3 over root 3. We just combine the tops to get 5 root 3. Remember, we like the whole number out front and the root on the right-hand side. And root 3 times root 3 is 3. Okay, so we know x is equal to this awful monstrosity, 5 root 3 over 3. And now we need the hypotenuse. It's equal to 2 times this. So 2 times 5 root 3 over 3. Oy, oy, oy. All that is saying we're going to multiply the 2 and the 5 together. That simplifies to 10 root 3 over 3. Unless you're a square root, you cannot, unless you're under the root, you can't fuss with or combine with the other root. The only time we can combine roots together is when they're under the same root. Okay. One more shot. This is it, and then we're all done with notes today. It was a great, long, strange trip. Okay, so we're looking at D. I'll put an iron fortress around it. Oh, here it is. So we're looking at D. Please draw the triangle. We need to identify which sides. Whose side are you on anyway? I'm on your side. This guy is across from the 90 degrees, so he is the hypotenuse. This guy is across from the 60 degrees, so he's the long leg. And that leaves X being Mr. Short. Fun fact, my grandpa was so short, even though his name was Marvin, they called him Shorty his whole life. And it is on his tombstone where he lay for eternity. Shorty Litwiller. Love that man. Okay. So hypotenuse, long leg, short leg. We are going to use the first rule. We're going to say the hypotenuse is equal to 2 times the short leg. So we've got the hypotenuse is 22 equals 2x. What does x have to equal, my friends? Oh, wait. What's x equal? No. No, okay. Yay! Okay, so we know that the hypotenuse is 22, the short side is 11, and then the long side is root 3 times shorty. Y, so it's root 3 times 11, but we don't like it like that. We like 11 in the front and the root in the back. Okay. How is this settling with everybody? Oh, we have another example. Oh my goodness. How dare we not get to this example? Okay. Sorry, I thought that was done. But this, obviously not. Okay, so we're going to do 3 more problems. This will go fast. Equilateral triangle. That is 180 degrees in a triangle. You're going to divvy it up evenly into 3 different angles. What is 180 divided by 3? 60. So this top, each angle is going to be 60 degrees. You're like, Miss Applegarth, this is not a 30, 60, 90 triangle. What are you doing to us? This is almost a 30, 60, 90 when we drop in our altitude. We now have a 30, 60, 90 on the right and a 30, 60, 90 on the left. We now are talking 30, 60, 90s. Half of 60 is 30. So we want to find the area of a triangle is 1/2 the base times the height. Thankfully, it's equilateral. So the base is going to be 6. Uh-oh. We are not going to know the height, so we're going to call that H. So if we just look at, I'll highlight it, if we just look at our 30, 60, 90 part, H is going to be the long side. It's across from the 60. Anything across from 60 is the long side. Six is the hypotenuse. And, oh, we can actually find this. If we know the whole thing is 6, the altitude cuts it in half. What's half of 6? 3. So we know that the short side is 3. All right, so we need to find this altitude. We are going to look at our 30, 60, 90 property. The long leg is √3 times the short leg. So the long leg, H, is equal to √3 times the short leg. We don't write it like that. We write it like 3√3. So we got 1/2 times 6 times 3√3 is our area. Thankfully, we don't have to sign the perimeter. Okay, half of 6 is 3. 3 times 3 is 9, and we don't have any other square roots to play with our square root that's in there, so it just stays √3. So the area is 9√3. While you guys are finishing that down, I will tell you the area of a parallelogram is base times height, just like a rectangle. That's the only reason I remember it so well. It's because it looks like, kind of looks like a funky rectangle, or funky rectangle. So their areas are the same. We know that the base, let's get a pen. We know that the base is 5. We do not know the height. Dang it, the height is not 4. Shoot. So we have to calculate the height. We know that the hypotenuse of this 30, 60, 90 triangle is 4. We can calculate the short side because 4 The hypotenuse is 2 times the short side. So we can say that the hypotenuse is 2 times the short side. Is that easy calculation? Too much? You guys got to get your calculators out? Or can we do it? We can do it. I don't even need a calculator. I'm just going to divide by 2. Our shorty is 2. Shorty's 2. And then using our special right triangle formula, we know that our height is root 2 times our short. Sorry, root 3 times the shorty. I got excited about the 2. So let me show you again. It's root 3 times the short. Root 3 times the short, but we write it as 2 root 3. Don't be fooled. Okay, so now let's find the area. The area is the base, which is 5, times the height, which we calculated to be 2 root 3. The only people that get to play with their square roots is other square roots. It's a very segregated world in math, and it's really like, sorry if that's offensive, but the only people that get to play with my root 3 are other square roots. So the area of this parallelogram is 5 times 2 root 3, or 10 root 3. We have one more. One more, not. You guys got this one? One more. What is the perimeter? Oh, they got us here. They're really getting us. What is the perimeter and area of this shape? Okay, my friends, this is a 45, 45, 90. This is the hypotenuse. This is the short leg. This is also the short leg. We know, I mean, think about this. Just because they don't write the 5 on the right-hand side doesn't mean that it's not also equal to 5. Oh, so this guy is equal to 5, and the hypotenuse is equal to 5. Root 2. 45, 45, 90. I'll toggle back. Hypotenuse is root 2 times the length. Yay. Okay. We know that this is 14. Oh, so we have all of our dimensions. Okay. So our perimeter is all of our sides added together. All of our outsides added together. So we're going to take a little march around the shape, and we're going to start with 5, and we're going to add in 14, and we're going to add in 5, and we're going to add in, oh shoot, 5 root 2, boo, that's a dumb one, and then we're going to add in 14, and then we come back, oh, we already got that 5. Okay, so once we take the march around, let's put together the things we can. So we can go 14 plus 5 plus 14 plus 5. So that's like 28 plus 10, or 38. And unless I have another root 2 chilling around, I cannot add anything to my 5 root 2. It's like an X. So we just let this chill as 38 plus 5 root 2. Because I don't want to get out my calculator, so it's just going to stay like that. Okay, so the area of this is going to be equal to the area of the rectangle plus the area of the triangle. Area of the rectangle is base times height. Area of the triangle is 1/2 base times height. We're going to put those two areas together to get our total area of this shape. So let's look at rectangle first. That is 14 times 5. Okay, let's look at our triangle. The base of our triangle is 5. And the height of our triangle is 5. Let's see, 14 times 5, is that 70?
Yep.
Sweet. 5 times 5 is 25. Half of 25 is 12.5. 70 plus 12.5 is 82.5. Double check my math before I call it good. And we have found the perimeter and the area of our little shapes. These are classic. You will see problems on your test, like similar to the area and perimeter problems. Okay, any questions? This is now